So yesterday I have shown you the interpretation of SPSS, interpretation of especially the linear regression. I have shown you how you have to write the equation of both unstandardized and standardized multiple, both simple linear regression and multiple linear regression based on the output that we got from SPSS. So how do we have to form as an equation, and what kind of interpretation that we have to give for that equation when we are interpreting the data, right? So once you are done with that, then we actually went into a concept called comparing means. Okay, I'll start sharing the screen. Okay, so got into a concept called the comparing means. 1 minute. Okay, this one. So comparing means, all right. So here we had used this. We did the analysis of we tried all these options. We tried one sample t-test, independent sample t-test, paired sample t-test, one way ANOVA, all these techniques that we do, assuming the fact that the data is normally distributed. We have tested also. There are several ways to test whether our dependent variable or whether our variables are normal or not. I can test it through this analyze descriptive statistics, go to explore, and you can test whether the data is normal or not. Okay, and we have also tested whether the data is fulfilling the assumption of homogeneity of means by checking the Leibniz score, right? So those things that we have done. So basically yesterday we studied the interpretation of linear regression, plus we had also studied how do we have to compare the means of sample, mean of the sample with the determined value. We used one sample t-test. How do we have to compare the means across two different samples? For that we used independent sample t-test. And how do we have to compare the means across paired sample? That means pre and post. For that we did this paired sample t-test. And if it is more than two group, we do have something called one-way ANOVA. Now I would like to slightly brush up this, maybe in 5-10 minutes, all these tests, and then go on to this equivalent non-parametric test. So one sample t-test, okay, I choose this. Yesterday we did this. So we have considered this height, okay, so, and then we have filtered all the females and we have considered only males. Okay, how did we do that? We went to an option called data, and then we went for something like select. All right, we got into something like if condition. We have mentioned gender is equal to 1, which filtered out all the females, and we had chosen only the males, okay, for our data. You can see that it's taking a bit time. Okay. It is not responding. Wait a moment. It's not responding. Just give me a moment. Somewhere the system is hanged. It is not giving any kind of response. I think I have to close it and try opening it, because there is some problem with this software, because from yesterday onwards it is running. 1 minute, give me a moment. So this is what we have done it yesterday. So give me a moment so that I can it is not responding anything. That's why. I'll reopen I will end the task of SPSS and I will reopen it. It should not be a problem. And I will slightly brush up what we discussed yesterday, and then we can go to the two, 3 new techniques that we have in our agenda. So one, we will be discussing about the non-parametric test, and we have a plan to cover up the multiple linear regression. Sorry, we have a plan to cover up this cluster analysis and as well as the factor analysis. Somewhere this is not responding. Wait. All right, done. So I will open the SPSS one more time. The search, click on OK, open. I'm opening SPSS because yesterday I didn't shut it down. That's why it's not responding. So basically, see, when we talk about the variables, we will be classifying the data analysis for variables into three major types. One is univariate analysis. Okay, univariate means there is only one variable, like mean, median, mode. Okay, these are all what we call it as univariate analysis, right? And then we have something called bivariate analysis. Bivariate means we are analyzing two variables like crosstab, okay, chi-square, all right. And then we have something called correlation, simple linear regression. These are all bivariate analysis where we will be analyzing two variables. And then we have something called multivariate analysis. Multivariate analysis, normally we use this term for analyzing more than two variables. So for this we'll be using things like factor analysis, cluster analysis and stuff like that. Okay, now I think we don't have much time, so let us straight away get into the equivalent non-parametric test. So yesterday I have covered you about how do we have to perform this one sample t-test, independent sample t-test, and paired sample t-test. Today I will tell you what is the equivalent for it. What is the equivalent of one sample t-test? Why do we have to go for equivalent for one sample t-test? An alternate for one sample t-test is there. When I come across a situation where the data is not normal, or if the data is not fulfilling any one of the assumptions of parametric test, then I have to go for its equivalent non-parametric test. Say for example, we can go for something like one sample t-test. In one sample t-test, the equivalent for this one sample t-test and one sample non-parametric test. Now, how do we have to do that? Now, I can go into something like I can consider the height. Okay, all right. So now here also I need to filter out the variables. First, I need to filter out the variables. For that, I'll close this. I will filter out the variables first. Select the case. Okay, this is where it got hanged. Let me check whether it is. If condition, go to gender, put equal to sign, right? The relational operator may have to. Okay. Why it is not showing? Okay. Gender. Okay. So it is not in this format. So I will copy this, put it in. It is actually accepting only the which is in the form of numbers. So that's why it is not accepting it. So I will paste it, and again I will copy this and I will put it here. That will solve the problem. Okay. Right, data. Let me check. Select case. Again, this that have to convert it to numeric. Okay, right, and then I have to let me check now whether I'm able to get it or not. Yes, now I'm able to get it. So now here gender is equal to 1. So 1 signifies that I'm choosing only the male by filtering out all the females. Now you can see that in the output, all the females are being crossed, right? So you can see the strike symbol is there. It indicates that I am filtering all the females and I am choosing only the males. Now I'm going to do the same analysis where I'm comparing whether the height of the male is actually at par with the national average of the male, provided I go for the non-parametric test. Non-parametric of one sample t-test, go for this height, right? Go for the height and go to settings, choose the test, okay. Right now here, a minute. Right. Here I am choosing 177. Click on run. Right. So now you will be getting the one non-parametric one sample t-test. You can see that it is processing. It's taking a bit time. Yeah. So you can see that in this test also, the when we are actually doing it against 177, which is the national average of male, you are actually rejecting the null hypothesis. That means that there is a significant differences there in terms of the average height of men of our class with that of the national average. Now, I'm filtering it back. I'm actually removing the filters. Click on all case. Right. And then I can also do other type of non-parametric tests, let's say independent sample t-test. Independent sample t-test, as you are aware, that we will be comparing the means across two groups. What does the mean here? Let's say that here the mean is height, gender. I'm bringing it, all right, and probably two or more independent samples. Already the test has been selected. I need not to choose anything. I don't think so. It has already been selected. So now just click on run. So now we have got the output. Now here also in this output, we are rejecting the null hypothesis. What is the null hypothesis? There is no difference. That is a null hypothesis. And we are rejecting it. Why it is lesser than 0.05, which indicate that there is a difference in height is there across gender, right? Then again, I'm doing it, analyze, go for the non-parametric test, right? So now this time you can go for this related samples. Okay, so in this case, 1 minute. Yeah. So like this, see, there are a lot of non-parametric tests there. See, what I'm saying is here you have this comparison. There are four kind of tests what we have performed. For one sample t-test, you can get the equivalent one sample. Again, for independent sample t-test, the equivalent test is that man witness, okay, Wilcoxon test. Okay, then for this paired sample t-test, okay, the equivalent is Wilcoxon signed rank test. And for one way ANOVA, where the equivalent is Kruskal-Wallis. So you have to go here, all right, and choose the appropriate options. Okay, you have to go here and choose the appropriate options in the settings. Go to settings, and I have told you about the Wilcoxon. Okay, this one you have to choose and you have to run the test. So like this, you can do for each and every option, and thereby you can find out the equivalent non-parametric test for all the parametric tests. And one more thing, always you try for a parametric test to the maximum extent possible. But in spite of all your best efforts, if you're not able to do the parametric test, then you can go for its equivalent non-parametric test by going through this part of analyze the non-parametric test. Okay, this is what it is. Now, when it comes to the response, anybody is having any doubt? Anybody is having any doubt in this? Anyone is having any doubt? No? Okay. So now I will share you the data for doing factor analysis and for cluster analysis, because I didn't get much response, because we need to have at least minimum 50 response for running the factor analysis. So what I will do is I will share you the standard data set for this SPSS, which you can open it and you can use this data for your practice also out of training. So this is yeah, personality factor analysis and cluster analysis. So these are the two data which I wanted to share it to you. So I will share it in the WhatsApp. Just give me one. Factor and cluster analysis data. SPSS. Okay. Now just give me a moment. So I'm actually sharing the data for factor analysis and cluster analysis to the WhatsApp group. You can use this data for performing the analysis. Okay, 1 minute. Okay, I'm going to just get it. Just give me a moment. Cluster. Okay. Downloading it. Yeah, got it. So I have shared you the data for factor and cluster analysis in the WhatsApp group. So now I will use the data. You can, if you're using your laptop with SPSS installed in it, you can open the file that I have shared. So first we are going to discuss about the factor analysis. Right. So analysis. Just give me a moment. I'll open the file. Okay. So now I have opened the file of SPSS. I will share the screen. Sorry about it. Okay, fine. So now you are able to see the screen of SPSS, okay, of factor analysis. Now, here, first we need to understand the concept of factor analysis. So you can see here, this is about the data. This data is having how many samples? This is how almost having how many number of samples? N number of samples. Okay, almost 459 samples are there. And when we talk about these variables, there are how many variables? Almost personality, 44 variables are also there. Now this data, first we are going to perform factor analysis. Now, what is meant by factor analysis? So, factor analysis is basically a data reduction technique where we are reducing the number of variables. Say here you can see that you have how many variables? You have totally 44 variables. Now, these 44 variables is actually related with the personality of a person, whether he is a talkative person, silent person, whether he is a disorganized person, whether he is a careful person, all those variables that we have captured. So before we get into the analysis part, we wanted to reduce the number of variables so that the variables does sense for it. So we wanted to reduce it for 3, 4, 5, whatever it is. So that is the ultimate goal of factor analysis. So factor analysis, you can reduce the number of variables, and those variables, it does really make some sense. It becomes easy for me to do the data analysis. Say for example, let's say that when we talk about students, you can see that students may be scoring marks in mathematics, English, science, okay, and you can also get some scores related to the statistics. So these scores we can categorize as a theory subject. Theory subjects like language, science, where problems are much not involved. And then we can put it under a category called problematic subjects like mathematics, statistics, engineering. These subjects are related with problematic subjects, and we can put it under the category of problem related subjects. This is, and there will be subjects like which is related to the lab, like electrical lab, computer science lab, electronics lab. This can be put under the category of lab. And there may be other items like cricket, co-curricular activities, dance, cultural arts. This can be categorized under something called these co-curricular activities. Now what we have done, we have reduced totally 10 to 15 subjects to some 4 categories, including theory subject, practical subject, problematic subject, and co and extracurricular related activities. Now this is the ultimate objective of factor analysis. Factor analysis is basically a data reduction technique where we are reducing the number of variables, say from 50 to 4 or from 100 to 3, whatever it is, right? Then the next important thing about factor analysis is that it can be also used as a segmentation technique. I have told you that let's say that if a particular student who's not good at academics, he is good at only co-curricular activities like sports, including cricket, football, culturals, and all. So this student is ideally a right segment for focusing on sports. Another student who is good only at theory subject, not on problematic subjects, theory subjects like language and all. So probably he may be a best fit for courses like arts and science. Somebody who is good at problematic subjects, not good at there's co-curricular activities or there's a theory and all, he can be a best fit for something like engineering. So now this can also be considered as a segmentation technique. So factor analysis is basically a data reduction technique. You can also use factor analysis for segmentation purpose. So in factor analysis, what actually we are doing is that we are trying to study the interrelationship between these variables, and based on the interrelationship, we are reducing the number of factors. In this example, I have told you that somebody who is good in language, let's say English, Kannada, Tamil, or whatever it is, no, you can see that they will be also good in other theoretical subjects. Somebody who is good at practical subjects, they may not like theoretical subjects, and their scores will be good in problematic related subjects. And somebody who is good at sports, he's just not good at cricket alone. He may be good at football, he may be good at extracurricular activities. So what happens is that this interrelationship constitute something called as factors. So based on the interrelationship only, we are actually dividing, we are actually grouping these variables as one component of component 1, component 2, component 3, like this. And then what do we do is that we name those components. Okay, and then after naming it, we use it for our analysis purpose. Now I will take you through the steps of factor analysis, and we will talk about the detailed interpretation of it based on that. Right. So go to analyze. Go to analyze. Are you all with me? Are you following along with me? Are you all in the same page? Yeah. So analyze dimension reduction, go to factor. Because why dimension reduction? I have told you that factor analysis is basically a dimension reduction technique. So here we have captured the personality of a person. Totally there are how many questions? Almost 25 plus questions which is related with the personality of a person, whether he is a talkative person, whether he finds faults, okay, whatnot. So I am choosing all those things and I'm bringing you towards the right hand side. And then I'm choosing something called descriptives. In descriptives, I'm choosing this coefficient, significant level, determinants, and KMO-Barter's test of veracity. Okay, and then click on continue. And then we have here something called extraction. So in extraction, we have several types is there. Generally, we choose something called principal component. So basically, see, factor analysis, there are different types out there. In fact, some people say that principal component is not a type of factor analysis, though they have given it into factor analysis, but the output of principal component is very close to the output of factor analysis. So basically, we can do this factor analysis through the output can be derived through common factor analysis and principal component one. But generally, people choose principal component one. The difference between principal component and common factor analysis is that in principal component we consider all the variations, all type of error terms we consider. In factor analysis we consider only those error terms which are in common. So that is deep into statistics, but in general, for our understanding, please understand and make it a point that we choose principal component for our factor analysis purpose. Right, and one important thing is that we choose always the eigenvalue which is greater than 1. So eigenvalue is nothing but it is the square of the sum of all factor loadings. Okay, I'll explain you about what is meant by this factor loadings. So I will also explain you about eigenvalue and what exactly it is, and how does it make sense to go ahead for the eigenvalue which is more than 1. And then here you have to choose something called scree plot, which give the graphical representation of the eigenvalue. Click on continue and go for rotation. So in rotation, there are several types of rotations are there. Generally, you can see people going for varimax rotation or direct oblimin. Okay, doesn't make much difference. Now, and why do we have to go for rotation is you have to understand the logic. I have told you that the factor analysis reduces the number of variables. Okay, from 50 to 4 or from 40 to 50, whatever, for 40 to 5. But during this process, you may come across instances where all the variables will be loaded in 1 or 2 factors alone. So this rotation, what it does, it is more like a steering where it distributes the loads across different components to the maximum extent possible. Okay, and this varimax and oblimin, it talks about different types of distribution of the rotation. Okay, so usually people go for this varimax rotation. So you can choose varimax rotation, and the scores you can save as variables. Okay, and then in the options, okay, here I'm not interested in getting the output of each and every the factors. I wanted to reduce it, the number of I'm actually suppressing those factor loadings which are lesser than not 0.10. I'm suppressing those which are lesser than 0.40. Okay, so that I'll get some understanding of about what type of loadings that I have got. Click on continue and click on OK. So once you have clicked on OK, now you can see the output. Okay, now you can see the output. So let us discuss it one by one. So let us start from the first table. Let's go to the first table. All right, here. Now this is the output of factor analysis. Now you can see that here first I have considered this correlation matrix, which talks about how the variables are interrelated with each other. It is not necessary that you need to report this finding, because sometimes the correlation matrix will be too big that you can't capture it in your thesis or in your research paper. Now this correlation matrix, you can see that if you can bring it towards the right hand side, you can see what are all the things which are highly correlated and whether it is significant or not. It is mentioned here. You can see that find a fault, let's say that it is not, yeah, it is minus 0, 1, 2, not highly correlated. This one is slightly correlated. So anything above this 0.7 is actually good. Okay, which talks about whether it is a positive correlation. So correlation is basically the one which is from -1 to +1. Minus sign indicate that it is negatively correlated. +1 indicate that it is positively correlated. If it is closer to -1, it indicates that it is highly negatively correlated. And if it is closer to 1, it indicates that it is highly positively correlated. 0 or close to 0 indicate that there is no correlation. So based on this interrelationship, we have got this factor analysis that I will discuss with you in the further steps. Now this is what we call it as Kamo-Bartlett's test of sphericity. Now this test, you have to look out for the sampling adequacy. It basically talks about, have we considered enough number of sample? It says yes, we have considered enough sample, because this value, anything above 0.5 is acceptable. 0.8 is fantastic. So now we have got 0.841. It indicates that yes, we have got good number of sample. So basically for factor analysis, we need to have a minimum of 50 sample. Otherwise 100 is well and good. Now we have got 461 sample. So this test, this assumptions of Kamo-Bartlett's test for the sampling adequacy, and it is significant also. So this you can report it. And then this is about the communalities, where among all the variables, you can see that the variable talkative and find a fault is having greater impact on the personality of the person. Okay, this is having a greater impact, talkativeness, and that means more number of people have chosen this talkativeness for this. And then that is why it is having the highest loading. Right now, this is what about variance is all about. So if you look at this variance, so variance talks about how many number of factors that we can reduce. So initially we have 44 variables. These 44 variables has been reduced to 10 different factors based on the variance, or sorry, based on the eigenvalues. So eigenvalue, we are using this eigenvalue as a cutoff point. That is, anything above 1, we are actually considering it as a component. What is this component? Component is nothing but the reduced variables. Earlier the number of variables were 44. This 44 we have reduced it to 10, right? So you can also find out the how many factors that we need to use, that we need to consider using this scree plot also. You can see that from 0 to 1, here it is 1. So from here 1 onwards, these are all the factors that you need to consider, right? So now, what is the eigenvalue? Which is nothing but the square of the sum of the variance. Now come down, all right? So this is the component matrix. Here you can see that some of the variables. Are you able to hear me? Because is there any network problem? Is there? No? Okay.
No, sir, audible, sir.
Sorry?
Sir, audible, sir.
Audible, okay. Now there's a component, if you can see that, you can see these variables are actually loaded. Okay, so whether it is positive or negative, that you can ignore it, because they might have done the reverse coding. So ignoring those signs, you can see that in component 1 you have the maximum number of loading. That is why component 1 is contributing the highest percentage of variance. All right, then component 2, the next component 3. Now here you can see there is one problem is there. When you go to this number 7, number 8, number 9, number 10, number 6, there are not enough number of loadings. So for that purpose, we have to consider rotation. Okay, we have to look out for this rotation. If you look out for this rotated component matrix, here the loadings are almost equally distributed across different factors. All right. Now this is something that you need to consider it as a final one for interpretation of the data. Now, if you look at this rotated components, you can see that some of the variables are having the high level of contribution for the first component. What do we have to consider it as? Anything above zero point 0.6 or anything above 0.5 is considered to be very, very good. Now, in this case, you can see that a person who has responded that he does a thorough job, he has also mentions that he is a reliable person. It is disorganized, he has given negative rating. It indicates that he is an organized person. Negative sign for lazy, that means that he is not a lazy person. So basically it captures the characteristics of a person who is a organized person. So now you can give the component one it as organized person. Second one, component 2, look at the characteristics. What are all the options that he has chosen? He has given a negative for talkative. That means that he is not a talkative person. Second one, reserved, positive, that is 0.785. All right. And then third one, he's a quiet person. Fourth one, he is a -463. You can ignore it. This one you can consider it a shy. So basically, it talks about the characteristics of a reserved person or an introvert. Third one, you look at it, the highest factor loading minus 0.747. It is minus. That means that he is not a relaxed person, tensed person. Okay, all right. And worries, emotionally stable. That means he's emotionally unstable. So basically, it talks about a tensed person who is not emotionally unstable. Okay, who is emotionally unstable. This one, component 4, it talks about helpfulness loading is very high. Then forgiving, next, but 0.461, not much loading. Look out for trusting, right? So basically, he is a forgiving, he is a helpful person who has a compassion towards the other people. And then look at this loading, full of energy, curious, generate enthusiasm. That means he's an energetic person. So 0.504, find false, okay? And here starts quarrels. Then cloud and aloof, moody. That means he's a fault finder kind of person. This one you can give. And seventh one, original, ingenious. That means he's a creative person, local, okay? Local and a creative person. Reflective. So now like this, you can give the name for it. So basically what you are doing it in factor analysis. First, you have to understand that factor analysis is basically a data reduction technique. It is a data reduction technique where it uses us to reduce the number of variables from 50 to 5 or 50 to 10 or whatever it is based on the eigenvalues. In factor analysis, we are actually reducing the number of variables based on the interrelationship between the variables. Once we have reduced it, we will be getting it in the form of component. And you can see that the component may get loaded into one particular factor or another. So what we do is that we rotate the component. Once we rotate the component, it is almost equally distributed. Once you're done with that, the last step of factor analysis is that you have to name that particular factor, right? Hope you have got an understanding of about the factor analysis. Yeah. Okay. So now we are going to the next technique called cluster analysis. Any doubt in this? Anybody is having any doubt on factor analysis? Where we have to use it? Anybody is having any doubt? No? Okay. Right. Then we can use something called cluster analysis. Now I'm going to open the data of cluster analysis. Again, one. And here it is organisms. Okay, click on open. So if you click on open, here we have captured the characteristics of some of the animals and plants, and we are trying to figure out whether it belongs to the whether it is a plant or whether it is an animal or whether it is a mammal or whether it is a reptile, what exactly it is, right? So for that purpose, if let's say for example earthworm, so earthworm is not having spine, it doesn't give milk, it is not an aquatic animal. So if it is no, we are giving it as 0. If it is yes, we are giving it as 1, right? So it does not have root, flies, all those things. Look at this cat. Cat is having a spine. It gives milk. It is not an aquatic. It does not have photosynthesis, no root. Okay, warm-blooded animal, yes. Hair fur, yes. Live birth. Okay, like okay then, like similarly like mushroom. So like this, we have considered some of the organisms. Okay, and we have categorized and we have mentioned their characteristics, whether it is having that characteristics, whether it is having that feature or not. So like this, we have captured it. Now, based on the cluster analysis, what we can do is that we can categorize these organisms into different groups, and we can say that, okay, hey, this belongs to reptile category, they belong to mammals, they belong to plants. So like this, we can categorize. Now, for this purpose, we use cluster analysis. So what did we talk about factor analysis? Factor analysis is a data reduction technique where we reduce the number of variables to very few variables. We are not discussing anything about the respondents. We are not talking anything about the respondents. In cluster analysis, instead of we reducing the number of variables, we are grouping the people who has given response. Okay, so this is not a data reduction technique. So here we are not reducing the number of questions or number of variables. Basically, we are grouping it. Okay, so in fact, political parties have actually used this. So now you can see that political parties, they may be having their own agenda, and based on their agenda, they can classify people as upper middle class, sensitive person, non-sensitive person, and they try promoting their promotional programs accordingly. So one organization which has effectively used cluster analysis in India is the political parties. If you will come across people who are highly dependent on media, so they will be targeting them accordingly. So right, so let us learn this cluster analysis. So there are two ways that we can do cluster analysis. One is that the most critical thing in cluster analysis is that determining how many number of clusters should be there. Do we need to have 2 groups, 3 groups, 4 groups, 5 groups? What exactly? That is most important thing. Now for that, I have to go for analyze, go for classify. Okay, go for classify. There are different types of cluster analysis. Now in this session, because of time constraint, I'm going to discuss about only 2 types. One is hierarchical cluster and another one is the k-means cluster. All right, so classify, first I go for hierarchical cluster. So through hierarchical cluster, I will figure out how many clusters that I can have. So here you can see that. Okay, all right, so bring those variables towards the right hand side. Please make it a point that there are totally 21 cases out there. Okay, 21 organisms that have captured. Go to statistics. In statistics, by default, there is an option called agglomeration schedule is chosen by default. Just leave it. Okay, click on continue, and then under plots, okay, don't choose dendrogram. It is a little bit difficult to identify the number of clusters based on dendrogram, at least for beginners. Go to methods. Okay, there are different methods out there, but the one which we are going to discuss today is that Ward's method. Okay, this is the method which we are going to use it for classifying the number of clusters. And squared Euclidean, it is chosen by default. Just leave it, don't do any change, save, nothing. Okay, just leave it. Click on OK. So once you have clicked on OK, so now as I have told you, I am using this hierarchical cluster analysis to figure out how many number of clusters that I can have. Look out for this Ward linkage agglomeration schedule. Come down, okay, come down. You can see that there are 20 items are there. Though there are 21, but it will always consider less than 1. Okay, so it is so how do you have to figure out how many number of clusters I need to have? You have to look out for the coefficients in our agglomeration schedule. Now look out for the last coefficient. So the last coefficient is 41.33. What is this 41.33? Is that this is the last one. If you look out for the one which is above, that is the 19th one, it is coming 23.9. That means the coefficient has reduced from 41 to 23. So what is the number? Approximately there is a reduction of 30, almost approximately there is a reduction of 18. Okay, 18 points has reduced. And from 23 to 11, there is a reduction of how many points? Approximately 9 points. Okay, sorry, much 12. All right, and then from 11 to 6, there is a reduction of 5, and from 5 to 6 to 4, there is a reduction of only 2, and here 1, and it is almost negligible. So for me, this is very much crucial, because from 41 to 23 there is a significant reduction, and from 23 to 11, of course, there is a significant reduction as there, and from 11 to 6, the reduction is not so significant. The reduction is not so significant when you compare that with 23 to 11 or from 41 to 23. So I am considering this 18. So I have to consider this particular value. Okay, I have to consider this value. Okay, and then how many number of cases were there? It is not 20, but basically it is 21. So 21 minus 18, you have to subtract it. 21 minus 18, you have to subtract. So 21 minus 18, 19, 20, 21. So basically 3 clusters. So how many clusters that we are having? 3 clusters. If you can also have 4 clusters also, it is up to you, because some people they feel I will consider this 6, because anyhow from 11 to 6 still there is a significant reduction is there, but I prefer to keep only till 18 because I don't want to have more number of clusters. So from this agglomeration schedule, I have come to know that we can have maximum of 3 clusters. Now once we have done that, you can go for this analyze. Okay, now go for this classify. This time you go for k-mean cluster. Earlier I have used hierarchical cluster. The objective was that to know how many number of clusters that I need to use. Here you go for k-mean cluster. In k-mean cluster, bring all the items, maybe except organism, because it will not accept. Okay, right. Okay. Iteration, no need. Save anything you want to save. No need. Right? Maybe you can have this ANOVA table also. Cluster information for each case. You can choose this. Organism, you can label case by organism. All right. Now click on OK. Oh, there is one option which I did not choose, where I need to mention the number of clusters. I'll do that one more time. Classify k-means number of clusters. By default it is 2, but as per the hierarchical clustering, we chose to have it as 3 clusters. Okay, this was one thing which I did not mention. Okay, so click on OK. Now let us analyze the output result. Now if you go through this, okay, quick clusters. Okay, now you can see that it is it has divided all these organisms into 3 major clusters. So you can see that if you come down, here, you can come down final clusters. Okay, now what it is, it basically talks about aquatic animals is falling under cluster 1, and then animals which are having spine, which are warm blood, hair fur, live birth, it is falling under cluster 2. And third cluster, organisms which does this photosynthesis, which is having roots, which is having seeds, and which is fixed, is falling under cluster 3. So basically, what is that understanding? What is that inference that I have got is that we have these 21 organisms can be broadly classified into 3 major categories. Cluster 1, it is aquatic, okay, aquatic organisms like fish. Second cluster is mammals, because it is having spine and it can give milk also, right? And third one is that it is having photosynthesis, and it does photosynthesis, and it is having roots also. So it comes under the category of plants and trees. So first one is aquatic organisms, second one is mammals, third one is plants and trees, right? So now these are all the 3 different one which we have added. And then we have also got this ANOVA table also. So this ANOVA table, it tells a lot of information about which is significant, which is not significant. You can see that there's spine, milk, all those things are significant. Slightly this flies is something which is not having that much amount of significance is there. You can have detailed interpretation of this ANOVA by doing this one-way ANOVA. For this purpose, I'm going to do this one-way ANOVA here. Analyze, comparing. Now, one important thing here is you will get this output. Okay, 1 minute. You can also get this output here. Organisms, cluster. Okay, that you have to choose it. Classify, K means right, cluster membership. This you will have to choose. I'm interested in categorizing what type of cluster that it belongs to. Let me check. All right, so now I have got it. So now here QCL, which indicate that the type of cluster, I will rename it as type of cluster. And there's 1, okay, here they have mentioned it as 1, 2, and 3. So 1 indicate that it is an aquatic animal, okay, and this one, Robin. Okay, 1 indicate that it is an aquatic animal. So now for this, I'm going to do something called one-way ANOVA. Right. So now here, bring all these things towards the right-hand side. Okay, and cluster number alone, bring it towards the factor. Right, and then you go for something called post hoc test. There are several options out there. You can go for this Bonferroni options. Okay, homogeneity of variance. Click on OK. Now you can see that look out for this ANOVA table. You can see that some of the characteristics of like spine is having significant relationship, which gives milk is having significant relationship, photosynthesis is having significant relationships. Okay, whether it flies or not, that alone is not having significant relationship. If you can analyze this post hoc test, you can see that there is a significant relationship between the characteristics, okay, and the type of cluster it belongs to. If you analyze this, of course, the cluster 1 and cluster 3 is not significantly related, okay, except that all other clusters are significantly related. So you can do this type of analysis also, but basically the main aim of cluster analysis is this one. I'm able to divide, or I'm able to group the respondent into different type of clusters, right? So So today I wanted to cover this factor and cluster analysis. I hope you would have got it. And we have also done this non-parametric test. Okay, so we can, if there is any doubt, I'm here to clarify it, because today is the last day. So I wanted to wind up at least 5-10 minutes before itself, so that if there is any doubt, I'll be in a position to help you out in your research or in your internship, whatever it is. Yes. Anybody is having any doubt on the topics what we have covered, or any general doubt which is related with the research?
Sir, one more, sir.
Tell me, sir.
Sir, actually, how to define how to correlation, regression, simple
Sir,
linear
sir.
regression.
Sir, can you please
Already how to 1 minute.
tell me, sir?
1 second. Sir, actually, how to define how to solve the issues in SPSS. But most of the cases, which of the areas you have to identify, sir, in relevant by research. For example, you have to see of marketing research area. At the time of which of the aspects you have to define, sir?
So you want to know how to use SPSS for marketing? Is that what you're asking, sir?
Which type of tool you use? That means mean, standard deviation, correlation, regression. These are the all tools are useful for marketing research.
Sir, actually, sir, now, yeah, you can mute it. If some background sound is coming, you can mute it. I'll tell you, sir. Sir, now here we have used the technique, okay? We have used different type of technique, and this technique is common across to all type of researchers or a student or a faculty. So you can be an engineering student, or you can be a management student who is interested in marketing or finance or HR. But this training program, we will be giving a overall view, overall overview of about these are all the different techniques that is available in SPSS. And now you as a researcher, it is up to you which technique that you are going to use. Right. Now coming to this domain of marketing, now I have shared you one survey which is related with impulse buying behavior. We all know that it is related with marketing. It is not a HR or it is not finance. Okay, it is related to marketing. Now it is up to you. It is an art. How do you have to convert that data, and you can use SPSS for that purpose, right? So you can see that I have asked several questions which captures the online buying behavior. Almost you can see almost I have captured some 20 to 25 statements. Do you think so, sir? I'm going to use all those 20 to 25 statements, or am I interested in reducing the 20 to 25 statements and then do the analysis? Which is a better choice? See, if you have taken the survey which I have shared related with online impulse buying, I might have asked some 20 to 25 statements, Likert scale. I'm interested in online buying, online offers, it attracts me, all those kind of statements. So basically it will come on 20 to 25. So what basically I have to do, I have to reduce the number of statements. How do I reduce it? I'll go for something called factor analysis, right? And then let's say that I have got people who says that offers, it actually motivates me to buy more online. This is one question which I have asked. Another question what I have asked. Now, another question what I have asked is that, well, what type of gender that you belongs to. Now, how do I use it for analysis? I can use SPSS to study how one variable is impacting another variable, right? So we have to identify, see, first what is that we have to do in marketing is that we have to design the questionnaire keeping the analysis part in our mind, and we have to identify the variables and study how these variables are talking with each other. This is what the entire analysis is all about. Okay, see, there is one test called chi-square test which I haven't taught you. If at all, if time is there, I can tell you. See, for example, you find some 10 people. 10 people, 6 of them are male, 2 of them are female. 6 of them are male, 4 of them are female. Out of 6, you find all 5 people are smoking. 1 person is not smoking among male. Out of 4, not all 4 are smoking among women. From this, can you make a hypothesis that in general male smokes? Whether you'll be able to prove it or not, the answer is I don't know. I have to do the test. That is where the role of SPSS comes into picture. It is basically all about how the variables are interrelated with each other. If you have understood this, then the other job becomes very, very easy, sir. Any other doubt? Anybody is having any other doubt?
No, sir. No, sir.
Yes, sir. Tell me, sir. Okay, there is one technique which I have not covered, which is chi-square, which is actually a non-parametric test, which is easy. Okay, I'll use the same example that I have told you. So I'll have two variables, and of this time I'm entering the variable. One is that gender, another one is that smoking. Okay, so gender, smoking. So gender, I will give it as right now I'll have it as numeric one. So let's say that one indicate that it is male and two indicate that it is female. One indicate that it is, one means it is male and two means it is female. Two means it is female. Okay, and the level of measurement is nominal. So obviously we can't use parametric test. We have to use a non-parametric test. Smoking indicate that, one indicate that yes I do smoke, two indicate that no I don't smoke. Or maybe I can use one for yes, one for yes, and zero for no. Zero for no. Okay, and here it does nominal. Now, what I'm going to do now, let us say that we have collected the 10 respondent. What is the first respondent? It is male. Okay, male, male, male. Sorry, male, 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 male. Okay, 4 of them are female. Sorry, female, 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 female. Smoking means yes, male smoke. Yes, 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 yes. One male don't smoke, does not smoke. So I'm giving it as no. Female, none of the female, they do smoke. Smoke. No. No. I've given the coding as 1 for male and 2 for female and 1 for yes and 0 for no. So you can change it here. Okay, it is up to us. Now from this I can also do analysis. That's what SPSS is all about. Now from this data, can I say that generally male smoke and generally female don't smoke? Can I make a statement like this? If the statement is proven, then the p-value should be lesser than 0.05. How do I check it out? Go to analyze, go to descriptive statistics, go to something like crosstab. On the row side, you take gender. On the column side, you take smoking. Okay, click on the chi-square. All right, and then click on continue. Cells, you can ignore other things, not a big deal. Click on OK. Right, now what does the data says? The data says that there are out of 6 male, 5 of them smokes, 1 don't smoke. Out of 4 females, none of them smokes. Okay, that is all 4 don't smoke. Now to check out, can I generalize? By taking a hypothesis, you have to look out for the p-value. The p-value is less than 0.05, which says that we are accepting the null hypothesis that there is a significant difference is there. Thus, we accept the alternate hypothesis and we reject the null hypothesis, which indicate that there is a significant difference between in terms of smoking across male and female. So generally I can say that male smoke and female smoke. That's for the verdict I can make. Now let us say that if I'm changing this data, let's say if any one female smoke, okay, then I'm redoing the analysis. Cross tab, okay, click on OK. Now you can see that it is not significant. That means that I can't generalize that male smoke and female don't smoke. Okay. Now this is the advantage of we having SPSS. You can do the similar thing in Excel also, but SPSS is way too easy compared to Excel when you're doing this type of analysis test. Yeah. So anybody is having any other doubt, any research related doubt that you're having? Anybody is having any other doubt?
Sir,
Go ahead, sir.
sir, will you prepare the control charts?
Sir?
Control charts. SQC, statistical quality control charts.
No, sir. Will you use Excel for what, sir?
Statistical quality control charts. That's, that means mean chart, range chart.
No, I use Excel for some normal operations like correlation, regression. For that purpose, I use Excel. For advanced technique, it is better I use SPSS because I found SPSS to be more user friendly compared to Excel. For basic operation like charts, like correlation and regression, I found Excel we can easily use it. But there are certain add-ins are there in Excel. Like there are some add-ins like Statistic Excel. You can get it for 30 days free, and after that you have to pay for it. In fact, my entire PhD dissertation where I have used factor analysis and that I have used it in Statistic Excel itself. That you can install it. It becomes self-explanatory for you to do that. So with add-ins, you can do all these tests in Excel. That is also easy, but you have to pay for it, say after 30 days. Anybody is having any other doubt?
Excuse me, sir.
Yes, ma'am.
Sir, this SPSS is an open source or is it commercial software?
No, actually for 30 days it is free, but there are few cracked versions are available. If you can source it among your friends, you will find some cracked versions are available. You just have to install the setup file, and there will be a path through which you can crack it. It is available in the market. Okay, though we can't get officially, it is there.
Okay, but it is not open source, right, sir?
Yeah, officially it is not open source, but you will find cracked sources are there. Till version 20 you will get it.
Okay, sir. Thank you, sir.
And one more thing,